Hearing will now come to order. I appreciate everyone's patience this morning, and thank you very, very much for being here. I'd like to welcome everyone. Right now, I can think of very few topics that are of greater interest to the American public than pocketbook impact of refueling our cars and still trying to hold within each household's budget. According to the Department of Energy, the average price of gasoline in the United States as of yesterday was $4.08 per gallon at the pump. At the gas station closest to here, the number that strikes me is the number that's north of $4.50. One thing we all agree on is that we must take action to help reduce the cost of transportation overall for families across this nation. Thus far, the national focus has been on cutting or restraining the rise of the cost of fuel. However, any of the proposed solutions will not have a palpable impact for years to come, but there are important steps that many cities and states are already taking to reduce fuel consumption and promote sustainability through changes in this transportation infrastructure, which includes roads and freeways, networks of stoplights, public transportation systems, and overall urban planning and design. Around the country, researchers in academia, industry, state and federal agencies have been working on developing innovative materials and technologies that reduce the life cycle energy costs of transportation infrastructure and promote sustainability. Pavements that incorporate waste materials that would otherwise be landfilled, traffic signal timing systems that cut congestion, and monitoring devices that can warn drivers to take alternate routes around traffic jams are just a few of the examples of innovations in transportation infrastructure and technology that can help protect our environment. The potential benefits of these innovative materials and technologies are impressive. Currently, the surface transportation sector accounts for 33% of carbon emissions in the United States. Additionally, according to the Texas Transportation Institute, congestion alone accounted for 2.9 billion gallons of wasted fuel in 2007. The Federal Highway Administration estimates that 5% of that congestion is due to poorly timed traffic signals. Intelligent transportation systems can eliminate congestion due to poor signal timing. That's a potential fuel savings of 145 million gallons of fuel per year. What's even more striking is that many of the technologies we need to bring about these fuel savings already exist. So why isn't every community in America using them? I'm very interested to hear our witnesses' thoughts on why policymakers opt not to use innovative materials and technologies as part of their transportation systems, and what the federal government can do to help spur technology transfer. I'm proud that in Portland, Oregon, and in the 1st Congressional District, which I'm pleased to represent, we have been leaders in using energy-efficient and sustainable transportation infrastructure. Technologies such as transit signal priorities that reduce idling by buses by linking onboard computers to traffic lights, ramp meters that cut congestion on our freeways, and real-time traffic information so that drivers can avoid backups. The state and local departments of transportation in Oregon have worked effectively to identify and implement innovative solutions to important transportation challenges. These efforts are coordinated regionally, not just city by city, so that energy savings benefit taxpayers and gasoline purchasers and other fuel purchasers throughout the area. Dr. Robert Bertini, who is director of the Oregon Transportation Research and Education Consortium, will tell us more about how the research and policy communities collaborate to make these projects a reality. Soon, the Congress will be considering the next surface transportation reauthorization. The Committee on Science and Technology plans to play an important role in defining our transportation research priorities for the future. Sustainability and energy efficiency are no longer just buzzwords in the transportation community. They are crucial components of a working national transportation infrastructure. Building more roads alone is not the answer. We must use our resources carefully and wisely, and that requires a commitment to reducing the creation of new materials and finding simple, innovative ways to conserve fuel. I'm confident that our panel today will give us some solid ideas for moving forward on a sustainable, energy-efficient transportation policy. And now I'd like to recognize my colleague and friend, the ranking member from Georgia, Dr. Gingrey, for an opening statement. Dr. Gingrey.
Good morning, Mr. Chairman, and good morning to our distinguished panel of witnesses. I want to first thank you for holding this hearing today, and this hearing that touches the lives of so many Americans on a daily basis. I am pleased to work with you as we continue this subcommittee's efforts to improve our nation's transportation infrastructure through innovative research and development activities that will hopefully result in a windfall of cost savings for our nation. While, excuse me, while the importance of our roads and highways to our economy and our way of life are self-evident, I'd like to take a moment to document for the subcommittee the extent of their impact. There are approximately 4 million miles of roads in this country, and Americans drive approximately 4 trillion miles per year. Furthermore, there are over 200 million cars and light trucks on the road, and a further 8 million trucks on the road supporting our businesses. So overall, transportation-related activities currently account for 10% of our gross domestic product. To support all this traffic, government expenditures on our highways are approximately $140 billion a year. Unfortunately, even with this constant influx of revenue, our infrastructure cannot support our growing traffic needs. According to the Urban Mobility Report published by Dr. Poe's Texas Transportation Institute, TTI, drivers in the Atlanta metropolitan area spend an average of 60 hours per year stuck in traffic, and they waste approximately 44 gallons of fuel in the process. This is my hometown, by the way. With gas prices currently at $4.08 per gallon, as the chairman said, for regular gasoline, this equates to almost $200 per driver that is wasted when families are struggling to pay for rising energy costs. Metropolitan Atlanta has similar congestion to Washington, D.C., San Francisco, and only Los Angeles has a greater congestion problem. Congestion, as we know, it's not limited to our major cities. Nationally, TTI estimates that congestion on our nation's roads resulted in 2.9 billion gallons of wasted fuel in 2007 and a $78 billion drain on our economy. Congestion aside, our transportation infrastructure accounts for a significant portion of our total energy consumption. Civilian transportation consumes nearly 9 million barrels of petroleum per day for gasoline, twice the amount of industrial uses. With oil prices now at about $135 per barrel, the total cost is a staggering $1.2 billion per day. Despite the numerous challenges presented by our transportation infrastructure, researchers across America are working right now on reducing our energy consumption and easing our congestion problems. Our panel will describe many technologies that can improve the condition and sustainability of our highways, both in the short and long terms. The priority of research and development in the transportation sector has lagged behind construction and rehabilitation. The challenges that now face our transportation infrastructure will require innovative design and technologies. So I'm eager to hear the panel's thoughts on how effective R&D activities have been in the past and how R&D should be included in, as David just mentioned, the next transportation bill. Chairman Wu, again, thank you for holding this hearing. It couldn't be more timely. I look forward to the panel and their testimony, and I yield back the balance of my time.
Thank you, Dr. Gingrey. If there are other members who wish to submit additional opening statements, your statements will be added to the record at this point. I am delighted to have such an expert group of witnesses before the subcommittee today to discuss this very, very important and timely topic. Mr. Paul Brubaker is the Administrator of the Research and Innovative Technology Administration of the U.S. Department of Transportation. Randell Iwasaki is the Chief Deputy Director of the California Department of Transportation. Good friend, Dr. Robert Bertini, especially welcome here in Washington, is the Director of the Oregon Transportation Research and Education Consortium, a university transportation center comprised of researchers from Portland State University, Oregon State University, the University of Oregon, and the Oregon Institute of Technology. Next, we have Mr. Gerald Voigt, President and CEO of the American Concrete Pavement Association, and Dr. Christopher Poe, the Assistant Director and Director of the Center on Tolling Research at the Texas Transportation Institute. As our witnesses already know, your spoken testimony should be a time for about 5 minutes. Your written testimony will be taken into the record in its entirety, and after your testimony, members of the committee will have 5 minutes for each round to ask questions, and we begin with Administrator Brubaker. Brubaker, please proceed.
Thank you, Chairman Wu. Dr. Gangrey, distinguished members of the committee. I have the privilege of representing the Research and Innovative Technology Administration at the United States Department of Transportation. Our job at RITA is to coordinate research across all of the various modes. And one of the things that we are interested in doing is to make sure that we have mechanisms in place to ensure the appropriate level of investment across the department in a variety of different areas, particularly those materials that can reduce life cycle energy cost and ensure sustainability for our transportation infrastructure. Mr. Chairman, our theme for the Research and Innovative Technology Administration is something we like to say, our tagline, if you will, our bumper sticker, is innovation for a nation on the move. And the key there is to ensure that we continue to be on the move. And the points you raised in your opening statement about intelligent transportation systems and the ability to reduce fuel consumption just by keeping traffic moving is a really excellent one, and it's one that we've devoted a significant amount of research dollars into, and we've got a number of university transportation centers across the country, including those at Portland State and those at Georgia Tech, that are engaged in, as well as other areas in the country that are engaged in that type of research to ensure that we're developing modern technology, the latest technology, taking advantage of commercial developments, as well as researching ways that we can integrate existing and future technologies, including things like nanotechnology, to ensure that those developments are incorporated into the infrastructure over time. That's on the intelligent transportation system side. We also are conducting significant research into recycled materials and those innovative materials and methods that can significantly reduce life cycle energy costs and make use of recycled materials. We've got a number of efforts underway, particularly those that we're working with industrial and commercial waste products, trying to figure out the best way to use waste material and industrial byproducts to achieve this this objective. And one example is that we currently see over 71 million tons of pulverized coal byproducts, or also known as fly ash, produced in the United States, and only about 39% of that fly ash is recycled or used for other purposes. Most of what's currently produced winds up in landfills, which, as we know, is a very environmentally unfriendly option. So pavements made with fly ash offer the potential for providing lower cost and, in fact, more durable pavement, and we're very interested in that type of research, and we're continuing to do that and support that through the department. Recycled tire fibers are also another technology that show great potential. And today, as we know, most old automobile tires wind up in landfills or they get incinerated, which is, again, not exactly a very environmentally friendly option. And what we're supporting right now, based on our experience with rubberized asphalt, we're supporting the use of recycled materials and trying to use recycled rubber to see if the performance that we experience with our rubberized asphalt projects using virgin synthetic fibers has the same durability and quality as that made with rubberized with the virgin synthetic fibers. Also, we're looking at nanotechnology, like I mentioned, and other cutting-edge innovation that may show some promise in reducing the long-term energy consumption and dramatically increasing the sustainability. For example, at the University or the Missouri University of Science and Technology in Rolla, Missouri, they're conducting a field test of bridge decking made with fiber-reinforced composites. What that's going to do, it eliminates the need for steel rebar, which obviously is energy intensive to produce that rebar. For reinforcement, but it also can significantly extend the life of the bridge, cutting down on replacement costs and the need to conduct repair of the bridge decking. Georgia Tech has some self-consolidating concretes that's going to reduce the maintenance costs and improve the durability and longer life of bridge structures. Federal Highway Administration is involved in a demonstration project for advanced material called ultra-high performance concrete. And we view those as pretty critical developments. There are also some challenges, though, which you asked us to address in the letter of invitation, and we view those that lie in two particular areas. One is standards development. Are there sufficient standards that exist to encourage the use of sustainable products and high energy efficient products, both in the construction and the repair of these materials? And then the second is the procurement process itself. Is the procurement process, and as you know, most of the actual implementation is done at the state and local level. Is the procurement process supportive and requiring these sustainable products? And those are the two areas that we see as the most significant challenges. So with that, that concludes my testimony, and I'd be delighted to answer any questions. Thank you.
Thank you. Are there any questions? Pardon me, I recognize Mr. Iwasaki.
I think I need more than 5 minutes, though. Would that be okay? All right, thank you. Good morning, members of the subcommittee. My name is Randy Iwasaki, and I'm the Chief Deputy Director at the California Department of Transportation. Now, I'm just going to get right into it. Government works the best when we have definite, clear-cut goals. In California, we have AB 32, the California Global Warming Solutions Act of 2006, and then the Governor Schwarzenegger signed an executive order which established climate change emission reduction targets for the state. We have to go back to the 1990 levels by 2020, so we have goals. Proposition 1B generated $19.925 billion for congestion relief in California. We have to take congestion levels down, the delay levels down to below today's level by 2016. So we have goals on our, not only on our climate change, on carbon reduction, but also on congestion. So I'm going to get right into it. Some of the innovative materials that we're looking at, and by the way, our budget is about $14 billion at Caltrans. Less than 20% of that's federal. So we're a state that helps ourselves. In the area of materials, I'm the Technical Coordinating Committee Chair of the Strategic Highway Research Program, SHARP 2 we call it, and I'm in the renewal section. We're looking at getting in, getting out, and staying out, basically rapid rehabilitation, minimize disruption, and create longer life facilities. In the area of materials, and by the way, what Congress can do is, it was set up at $450 million, it was cut to $150 million, and then besides renewal, there's congestion, there's capacity, reliability, and safety as well, research in that area. When we talk about materials, we're looking at longer lasting. We're looking at recycling. We're actually doing recycling projects in California. Rubberized asphalt concrete, Administrator Brubaker talked about that. 30% of our program, asphalt concrete rehabilitation, is done with asphalt rubber. We're looking at warm asphalt. You don't have to heat it as high, so therefore you don't burn as much fuel. And we recently received an EPA award for environmentally friendly concrete and cement. You wonder, what is that? Well, on the San Francisco-Oakland Bay Bridge and the foundations, we poured concrete that had 50% fly ash in it. So in California, probably anywhere else, when you manufacture cement, 1 pound of cement equals 1 pound of CO2. It's a little bit less, but for practical purposes, it's 1 for 1. And so 2% of our greenhouse gas emissions are cement manufacturing. And so we're trying to reduce the amount of cement, but still get the same strength and durability, because the last thing you want is your facility to wear out faster and have to redo it sooner, because you're just going to spend money there. The last thing in the area of materials is we need to get in and get out. We need to do it rapidly. Get the facility in the hands of the traveling public sooner. So we're doing it very, very quickly. We're looking at fuels. We're the first state agency, the major buyer of low sulfur diesel in California 5 or 6 years ago. People wonder, why are you buying that expensive fuel? Well, today they know, because all fuel sold in California diesel is low sulfur. And so we started that program. Hydrogen, we're going to build a hydrogen fueling facility in our Shop 7 in Los Angeles, equipment shop. E85, we're building facilities throughout California. How you can help us is we need one standard specification for the hardware so that it doesn't fluctuate and we get into conflict with the fire marshal. In the area of technology, there's so much technology out there that it's hard to explain, but the problem is integrated into the transportation system. So I'll talk about LED lights. It's a simple technology. We started working on that 15 years ago because our controller box would kick out because of the heat. Today, many states use LEDs. It's a lower draw, it's an energy saving, it's sustainable. We're proud to say that we're the only recipient so far of the Safe Trip 21 effort. It's along the lines of VII, Vehicle Infrastructure Integration Program, where cars talk to cars, cars talk to the infrastructure. One of these days, those cars are going to refuse to crash, refuse to run off the road. But in order to expedite that program, we applied for a Safe Trip 21 grant, and that's where the communication technology is not embedded in the car, but it's actually in consumer mobile devices. You know them as cell phones. And so we're going to take 10,000 cell phones and run them through the Bay Area, and we're going to get arterial information, probe information, so that you can take your trip faster. Not shortest distance, but quickest time. What does that mean? You're in your car less, you burn less fuel. We think that has a lot of potential. Travel information, we're beefing up our 511 systems. We want people to have up-to-date information to make mode choices, put people in other modes of transportation. And lastly, on the technology, we just opened a system-wide adaptive ramp metering where we have 35-mile-an-hour mainline flows, and we adjust each meter along the 210 in Los Angeles to maximize throughput. And then we're looking at electronic tolling. You wonder, how does California do it? We open up our right-of-way for deployment. When the ITS World Congress came to San Francisco in 2005, we did a call for submission with the private sector. It's a three-legged stool for deployment of technologies, academia, government, and the private sector. We don't build anything in state government. But when the ITS World Congress came to Sacramento, we opened up our right-of-way. We've got some great partnerships there, and it morphed into the ultra successful Innovative Mobility Showcase where you could touch ITS. We have 2 test beds for mobility, one on Interstate 80 near Berkeley, the other one on I-405 near UC Irvine. We fully fund our UTCs. We have 5 in the state. We partner with Transportation Research Board, AASHTO, ITS America, U.S. Department of Transportation, Federal Highway Administration, and others. We have joint research programs with other nations. We do mobility research for the last 20 years with France. We do material research with Denmark. We do seismic research with Taiwan and Japan. States should probably play in the deployment of technology because we need the overarching standards. We don't want the widget or the product not to work when you cross state lines or county lines. We have to have interoperability. Some of the impediments is on the federal side. When it's a federally oversighted project, if we have a new mix design, it takes time to get those approvals. At the end of the day, the states are responsible for our rehabilitation projects. So if something happens, they don't come back to Federal Highway Administration, they come back to the states. The non-competitive bid, we have patent laws in the United States that allow private sector to develop new widgets, new technology. But when you try to deploy them on a project, you have to go through a PIF process. That's a public interest form. It takes time. And so we're trained not to go through the PIF process. But how do you get innovation if you don't go through the PIF process? I think, since I'm red now, and I have so much to say, demo projects, back in 1970, then Governor Ron Reagan flipped the switch on the first Transportation Management Center in Los Angeles. Today, Transportation Management Centers are spread throughout the United States. We need deployment. We need demo projects. AASHTO sponsors a number of scans that go throughout the nation, as well as internationally, to look at technology and how they deploy those technologies so we don't have to reinvent the wheel. We use our strategic plan at Caltrans to help guide our research program. The last thing I would say is we need people to maintain, operate, design, and build these systems. That's where the UTCs come into play. They teach the next generation of leaders. We need to get people in the trades. And so thank you very much for your time.
Thank you, Mr. Iwasaki. The chair now recognizes Dr. Bertini.
Thank you very much, Representative Wilson. Good morning, Chairman Wu and members of the subcommittee. Thank you for this opportunity. Approximately two-thirds of our ongoing research at OTREC address energy efficiency and sustainability by aiming to improve the operation of the multimodal transportation system. Increasing efficiency means improving safety, reducing congestion, and encouraging more energy-efficient travel. When the total amount of travel time or number of trips is reduced, there's always an accompanying benefit in reduced fuel consumption, energy use, emissions, and other externalities such as noise, accident exposure, and contribution to urban heat islands. Public transit also benefits by reduced travel times and increased reliability. Projects from the Intelligent Transportation Systems, or ITS, toolbox include new pricing and tolling strategies, integrated corridor management, incident management, ramp metering, measuring arterial performance, and improved traffic signal coordination using adaptive systems. Also, at OTREC, a joint project with the University of Minnesota is examining how drivers value travel time reliability, which is important for implementing advanced traveler information systems. How do we determine the potential environmental impact of a given technology? Typically, an evaluation will include standard performance metrics such as travel time and reliability, emissions and noise, number of trips, mode choice, and fuel and energy consumption. We use national resources such as the U.S. DOT's ITS benefits database and the Intelligent Transportation Systems Deployment Analysis System, or IDAS. For a successful evaluation, there are several critical ingredients based on my experience. Strong partnerships with transportation agencies and industry, careful identification of the problem to be addressed by the technology, a freely available data source, preferably as part of the technology deployment itself, the ability to measure performance both before and after deployment, early involvement by the evaluator, use of a test bed, and technology transfer before and after and during the evaluation. We still have many research needs in order to improve the energy efficiency and sustainability of the transportation system. Our focus at OTREC is shifting toward efficient and sustainable operation of the transportation system, which requires new financing systems with energy efficiency and sustainability goals.
Dr. Bertini,
Yes.
sorry to interrupt you.
Sure.
But we're going to have to suspend the hearing for just a minute.
Okay.
We've got votes to do, and I've got 2 minutes to get over there. Mr.
problem.
Wu should be back in just a few minutes. I apologize. I apologize to everybody, but we need to vote. Excuse me.
Thank you.
it is somewhat interesting and ironic that in the midst of discussing time, motion, and traffic management, we are doing that sort of on a different scale, a small, minor scale, such as we deal with it here. This is not quite the equivalent of a bus going sideways on a narrow transportation corridor, but let's just say that this is a not uncommon, but just a change in traffic flow to which we are adjusting. Dr. Bertini, I understand, we made a valiant attempt to keep the flow going and choreograph something up here on the dais. My understanding is that there may be some further unexpected changes or not planned for changes as we go. With the cooperation of the minority members, my understanding is that whether minority members are present or not, that we're good to go with further testimony and probably with some of the questions. And we'll just see what happens on the House floor as we proceed. My apologies to the witnesses and the attendees. This is the process of checks and balances that protects our liberties. An efficient government would more effectively take away your liberties, our liberties. It's friction that allows us to travel, isn't it? With that, Dr. Bertini, let's reset the clock a little bit and be more generous with your time. Please proceed.
Thank you very much, Chairman Wu. I was beginning to talk about our future research needs, and I had mentioned the need for a new financing system with energy efficiency and sustainability goals. Mr. Iwasaki talked about how we respond well to very specific goals. I also believe we need to pursue full and aggressive implementation of ITS-based congestion management strategies, including ramp metering, speed harmonization, and traveler information. In addition, a robust, high-quality, and secure data collection infrastructure, ideally built upon Oregon's open data sharing philosophy and including a mix of public and private sources. Better management of arterials for all modes requires modern traffic signal systems, communications, and data collection. Accurate, timely, and customized traveler information. A clearinghouse for obtaining freight data will be needed for managing freight transport. Green performance measures that can be generated and compared across different geographic areas and across all modes. Standard traveler information graphics to replace text-based dynamic message signs. Solving legal and institutional issues for automated enforcement. And serious exploration of liability issues following the lead of the European Union and Japan related to technology deployment. Now, there are many challenges impeding the use of innovative technologies in transportation. Some examples include the incomplete shift to an operations environment in transportation agencies, finance and funding, human resources in a multidisciplinary world, legacy systems and system integration, communications infrastructure, data quality, reliability, and availability, the need for collaboration, and the need for objective and continuing evaluation. There are many actions that can be taken by federal, state, and local governments in order to break down barriers to the application of innovative technologies. Several examples would include encouragement of regional collaboration across modes and jurisdictional boundaries, include the private sector and academia. Encourage public-private partnerships for data sharing and communications, funding and incentives for green operations, reward data sharing, continuing education and mentorship from transportation professionals, as I mentioned earlier, green performance measurement and evaluation, and expansion of the rural infrastructure. Now, regarding technology transfer, industry and academia play important roles in the implementation of technology solutions, and through collaboration, such as with the UTC program under RITA's leadership, universities can work with transportation agencies and industry to provide unbiased, rigorous evaluations that complete the feedback loop in the project development cycle. In the ITS field, academia can play an important role in the collection, storage, and maintenance of data archives. Now, OTREC has been in operation for about 18 months, and our technology transfer efforts have been successful so far, and we hope that will continue. In order to accomplish that, we have about 30 external public and private matching partners who have a vested interest in the success of the research that we're pursuing. External partners serve on our advisory board and assist with the peer review of our products. We believe that these efforts will help get the results into the hands of those who can implement them in the transportation field. In addition, our educational programs are preparing future transportation professionals and providing opportunities for working professionals to seek additional education and training. Our website, publications, videos, podcasts that are available through iTunes, by the way, our online seminars, short courses, and conferences. We even have a Facebook page for those of you younger generation. They all contribute towards the important technology transfer. Our theme of healthy communities, integration of land use and transportation, and advanced technologies is guiding us along with our agency and industry partners to develop research and education programs to solve transportation problems and strengthen the transportation workforce. Our research is being developed through a collaborative process and the important component of peer review. Thank you for this opportunity, and I look forward to working with you to make a more sustainable and intelligent future in our transportation.
Thank you, Dr. Bertini. Mr. Voigt, please proceed.
Thank you. Good morning, Chairman Wu and distinguished members of the subcommittee. It's both my pleasure and privilege to represent the 460 members of the American Concrete Pavement Association before you today. I will address two areas: how paving materials can contribute to energy efficiency and sustainability, and what challenges impede the adoption and implementation of sustainable practices. Concrete is inherently a long-lasting and renewable building material. One of the unique distinguishing factors and features of concrete pavements are their well-documented durability and longevity over many decades of evaluation. Most pavements have a design life of 20 years, but concrete pavements generally last much longer. In fact, there are cases of heavily trafficked concrete pavements that have performed for longer than 40 or even 50 years. A good local example is Interstate 66 just outside the Beltway here in the Capital Region, which was completed in 1963 and is still in service today, carrying a daily traffic level 10 times what it was designed for. There are many other examples like that across the country. According to research in Canada, it is this exceptional longevity that is primarily responsible for enhanced sustainability benefits, particularly fewer repair cycles, which is the primary reason concrete pavements have a significantly lower energy footprint than comparable asphalt pavements. Although cement, the glue that binds all the rocks and sand together in a concrete mixture, requires a significant amount of energy during manufacturing, it makes up only about 8% of the volume of a typical concrete paving mixture. Over the past 2 decades, the trend has been for less Portland cement to be used per cubic yard of concrete, largely because of improved mixture technology and the industry's significant use of industrial byproducts, which I believe were mentioned earlier, such as fly ash from coal-fired energy plants and slag from iron blast furnaces. Concrete is also 100% recyclable and reusable. There are a number of sustainability features and benefits that concrete pavement provides in addition to those based just on materials. For example, concrete roadways require about 1/5 the energy to produce as comparable asphalt pavement. If concrete were substituted for the 500 million tons of asphalt used in roadways each year, it would save around 1.2 billion gallons of diesel fuel used in construction, or roughly the equivalent of removing 2.7 million cars off the road annually. I would like to point out that we're not suggesting that every road in America needs to be concrete. We're just trying to make the illustration of the benefits and the sustainability features that concrete provides. According to the National Research Council of Canada, trucks traveling on concrete pavements use up to 6.9% less fuel than on asphalt. So if all asphalt surfaces on the national highway system were concrete, it would save as much as 2.1 billion gallons of diesel fuel per year, or $8.2 billion at $4 a gallon. Concrete pavements are also naturally light-colored, reflect light, and do not retain as much heat as darker-colored pavements. This could save cities and municipalities up to 1/3 on energy costs associated with street lights. Concrete pavements also have a direct effect on mitigating urban heat islands. and have been used successfully with other light-colored surface technology to reduce urban temperatures. According to Lawrence Berkeley Laboratories, the potential energy savings in the United States from this approach is estimated at $5 billion per year through reduced cooling costs in those cities. In terms of the current and needed future research and technology activities, at the top of the list for us is a new sustainability technology initiative within our industry's long-range research roadmap, which will encompass a wide range of activities to close research and technology transfer gaps. We have outlined these in our written testimony. Lastly, I want to mention several challenges our industry sees to further implementation of sustainable materials and practices for transportation infrastructure. First, there's a lack of clear and universally a clear and universally accepted way to measure the sustainability of roadways. Second, current specifications should be replaced with specifications that require more sustainable practices. In many cases, existing specifications unintentionally limit the use of more sustainable materials, like blended Portland cements. Demonstration projects and workforce training at all levels will be necessary to develop the knowledge and skills to implement sustainable and innovative technology. And there's also an acute need for a design and decision tool or tools to assess and continually improve the sustainability of all pavements. At present, most pavement decisions are based on first cost and to a limited degree life cycle cost without regard to sustainability factors and benefits. A stronger federal position with an objective and more comprehensive pavement selection policy would help ensure that agencies effectively apply appropriate considerations for energy use and sustainability. The decision process must change to impact the use of innovative and current materials that are more sustainable and less costly in the long run. Mr. Chairman, the stakeholders in our nation's surface transportation network currently stand at an important fork in the road. We can let our surface transportation network continue to erode through the continuation of current practices, or we can reinvest in new practices and quality materials that contribute to sustainable development. Our industry looks forward to continuing this dialogue with you. Thank you for the opportunity.
Thank you, Mr. Voigt. And we have another vote called on the floor, and we also have a request from the minority side that we pause the testimony at this point so that a larger number of members can listen to the witnesses and participate in the Q&As. And that is a request which the chair intends to honor. So with your forbearance, we're going to pause the testimony for a moment and continue when the members have had an opportunity to return. Thank you for your forbearance. this point, I'd like to resume witness testimony. Dr. Poe, please proceed.
Chairman Wu, members of the subcommittee, thank you very much for the opportunity to testify today. As you know, the nation's transportation system has a substantial impact not only on our economy, but on the environment as well. In addition to impacting air and water quality, it affects our energy efficiency and sustainability. The Texas Transportation Institute's environmental research encompasses air, water, and soil studies, as well as roadway landscaping and environmental management and control. In my written testimony, I provided examples of how TTI is testing new pavements that reduce water runoff, noise, and air pollution. TTI is also studying how technologies and products reduce soil erosion and impacts on ecosystems. However, in the interest of time, I would like to focus this morning on the issue of traffic congestion and how it's affecting the environment. Some may say some congestion is a sign of growth and economic development, but is also a sign of waste. In 2005 alone, we as a nation wasted 2.9 billion gallons of fuel in the urban areas of our country. And that does not count the rural areas where traffic tie-ups and a number of other causes stress our road network. TTI has worked to help mitigate this problem through more accurate data gathering, improved reporting, and developing intelligent transportation system technologies to link the various components of the transportation system together. We're also working to solve this problem through projects such as the Dallas Area Integrated Corridor Management Project, which will provide state, transit, and local agencies comparative travel data, which they can then provide to the public to help travelers avoid congestion and select the best routes and modes. By using cities such as Dallas, San Antonio, and Houston as real-time laboratories, research findings and technology transfer occurs instantaneously as we work with our counterparts from local transportation agencies and private industry on a daily basis. What is the benefit-cost ratio of decreasing congestion? Well, in a series of studies from 2003 to 2006 for the Texas Governor's Business Council, the Texas Department of Transportation, and the Texas Metropolitan Planning Organization, researchers at TTI estimated that investment of $66 billion in efforts to eliminate congestion and improve mobility would generate $540 billion in savings from lower travel delay, reduced fuel consumption, and increased business efficiency, an 8-to-1 return on investment. By reducing stop-and-go driving, researchers estimate that Texans could save as much as $37 billion in fuel consumption alone, and that was done when gasoline was at $3 a gallon. What are the impediments to solving this problem? Well, the first is money. $66 billion is a lot of money. Secondly, at a time with increasing gas and grocery prices, we must effectively communicate the need, how it will be addressed, and the resulting benefits. To communicate more effectively, we must first improve even further our ability to gather data, interpret the impacts of transportation on the environment today, and more importantly, how transportation improvements will affect the environment tomorrow. This will give us firm footing in terms of benchmarking progress. As for the solutions, there is not a one-size-fits-all approach that works. Decreasing congestion, emissions, and fuel consumption will require all of the stakeholders, public and private, federal, state, and local, to come together, share information, and work together to ensure that we as a nation can continue to grow our economy, but do it in a way that protects our environment. TTI was established 58 years ago as the research arm of the state of Texas. Even from the early days, the groundwork of the business plan of the Institute had been established. That is to say that we primarily are sponsor-driven. Today, research funding comes from federal, state, and local governments or private industry. While this approach works well to address short-term and mid-term solutions, we are also fortunate that we have received federal funding through projects such as the TransLink Laboratory and Research Center and the University Transportation Center for Mobility. These projects provide multi-year funding, which enable researchers at the Institute to look at nationwide problems in the long term. Addressing the impact of our nation's transportation system on the environment will require a comprehensive multi-year program. Even at TTI, with our long history and broad-ranging environmental research program, we have had to seek solutions one project at a time. Without a national, comprehensive, long-range approach, our program will only be successful at incremental advances rather than providing major solutions. That is why your effort to advance green transportation are so important. The University Transportation Center, as part of that initiative, provides multi-year funding, which is important to solving long-term problems. It also provides a well-established process for getting research into practice and training the transportation industry. In addition, this research program model has been successful in providing the research and academic community more input into setting the research agenda at the federal and state levels, while ensuring continued cooperation and input of all the other stakeholders in our nation's transportation system. With that, I'll conclude my remarks. I appreciate the opportunity.
Thank you very much, Dr. Poe. And at this point, we will begin with the first round of questions. And as chair, I recognize myself for 5 minutes. For the next major surface transportation reauthorization, which is coming up very soon, I'd like to ask of each of the witnesses what you all think are the key research priorities for the nation for surface transportation in this next bill, especially in the context of reducing life cycle energy use and promoting sustainability. Whoever is ready can proceed, but if Mr. Brubaker, you'd like to start, perhaps we can just sweep from my left to my right.
Okay, Mr. Chairman, sounds great. I would suggest that I think we've laid the ground for, as we've laid out our priorities for research in the department, particularly in the areas of materials. We've divided up the research portfolio into communities of interest, one of which is materials, and focusing on that and ensuring that there's enough visibility and enough investment going into that particular arena, both in terms of basic research development, some applied research development, particularly focusing on the applied side and then the technology transfer activities. I think that would be most helpful, as well as the continuation of the intelligent transportation system portfolio, but to make sure that it is focused in such a way as you described in your opening statement.
Thank you. Mr. Iwasaki?
I think that the way the research program is set up currently, it's a good one. The problem is it doesn't have enough money, and I mentioned in my testimony that the Strategic Highway Research Program was set up for $450 million, and it was reduced to $150 million. There's some key components that are left that we could take a look at on not only congestion relief, but on the material side as well, and being able to do our jobs faster, better, and for less money. So I think that make it performance-based, however you do it, but I think we ought to add more money to the research program nationwide. Percentage-wise, in the transportation business, it's a small amount of money versus what other facets of industry looks at. The other thing is those demonstration projects are pretty critical, and we'd be willing to submit any performance-based criteria proposal to Congress to get some of that money. I think California competes very well, and we love to compete, and we're very aggressive at it. And so maybe more deployment or demonstration projects, and then couple that with the resources necessary to get the word out on the benefits of those demonstration projects.
Sure. For the reauthorization, there are a couple points that I made earlier. The first one is the data infrastructure. So if we want to have a transportation system that is sustainable and green, we need to be able to measure that. And so having the infrastructure for robust data collection and evaluation is really important. Evaluation, we talk about 1% for art in government-funded buildings and projects. I sometimes talk about X% for evaluation. Sometimes I say 4% if I'm talking about a project in the city of Portland in the safety area that we have going. Randy mentioned this need for ongoing, thinking of setting aside a percentage of what we do for evaluation and monitoring. And then I guess the idea of green performance measures. So we talk often about reducing congestion, reducing delay, but I think the general public is not really aware of what the, let's say, sustainability impacts of that are, the fuel consumption, emissions, noise, and so on.
Thank you. I think our industry's picture of what would be needed in research is probably best split into two major focus areas. The first being with regard to the material side and things we can do to further enhance the sustainability in use of materials within concrete, particularly recycling methods. There's a great ability to recycle concrete and use it back into the mixtures that are used directly in highways. There are a lot of agencies that are reluctant to do that in certain areas. We feel that there's a lot more opportunity there, as well as further use, and I believe it was mentioned earlier in one of the remarks with regard to further use of fly ash and further use of slag as part of concrete mixtures. There are blended cements that are manufactured by the U.S. cement industry that are not routinely used in highway pavements that could be routinely used in highway pavements, and they would have a sustainability benefit. So there are a number of associated materials issues that could be addressed. We also see the other side of looking at the sustainability of the use of the paving structures, and by that, what we're getting at is some of those things I directed in my my comments earlier with regard to the fuel efficiency of vehicles on the pavements, the lighting and energy savings that could be derived by the reflectivity of the pavements, and those associated benefits in energy savings that we are not currently accounting for in the selection and the use of pavement systems. And so we see need for research and further development of our understanding along those areas, coupled with a decision framework that needs to be put into place to include those sustainability benefits as part of the selection criteria. And that simply is not happening right now. It's purely a cost basis method of selection that's being used. So we see a need along those lines.
Thank you. Dr. Poe? Dr. Poe,
there we go. Sorry.
There you go.
Two things. Let me echo Dr. Bertini's comments about evaluation. If we are going to challenge the industry to do things differently, new transportation solutions, we better know the impact of those and what the relationship between those transportation solutions are and the impact in our environment. And that closely ties and measure and be able to evaluate is highly important. The second thing is in green transportation is a very broad topic. It has involves researchers and industry working in all different parts. And by bringing currently, right now, they're kind of working in their areas. And by bringing attention to green transportation and allowing it to come under one umbrella and getting those collaborations between the research environment and industry working together on one solution, how do we reduce the impact on our environment, will go a long way in reauthorization to come up with good solutions.
Terrific. Thank you very much to all the witnesses. And Dr. Gingrey, recognized for 5 minutes.
Mr. Chairman, thank you. I was at a meeting early this morning, the Oversight and Investigation Subcommittee of House Armed Services, of which I'm a member, and we were talking about making sure that people understand the difference in a strategic plan and how that leads to policy and operational activity. And so I want to ask a real direct, simple question of all the witnesses and start with Dr. Brubaker. And that is, what do you think is the single most important thing that the federal government could do to increase adoption of new transportation technologies from a strategic perspective as we go forward to set policy for the 21st century in regard to surface transportation?
I'm glad you asked that question. Fundamentally, knowledge sharing, and it's an area of focus that we've put into our strategic plan. But the good news about having it in our strategic plan is we've actually made it actionable. We're actually coming up with a construct to share knowledge, particularly and beginning with the university transportation centers. It's very it was very telling when I took over this organization that we had a lot of great activity going on in various university transportation centers and out in the research community generally, but that knowledge, that research, wasn't being shared amongst researchers who were doing work in similar areas. That's one aspect of it. The other aspect of it is we'd have these great meetings where the research community might get together once a year, in particular at TRB, Transportation Research Board's annual meeting, and they would communicate with other researchers as opposed to making a concerted effort to share knowledge, capture that knowledge, and be able to transfer that knowledge to the private sector or to not-for-profits who could actually look at commercializing some of these things and deploying them and develop standards that you could actually use for deploying these technologies and getting them out in the field. So that's key to us.
Thank you, Mr. Iwasaki.
I think the best way to phrase this would be, in our strategic plan, we have guiding principles, and one of our guiding principles is innovation. And there's a lot of mothers and fathers of innovation when it works right. There are no takers when it doesn't work. And so how does the federal government help states deploy innovation is accept some of the risk. Take a risk. Don't make us go through these arduous review processes and get that technology deployed sooner, because at the end of the day, it's just costing us more money. So it's going to take some time. But I think on a strategic level, accept some more risk.
Dr. Bertini in Oregon.
I would say, if I had to say one word, I would say incentives. So there are incentives built into the way transportation systems are developed now. People are rewarded by feeling proud about a big project, a big bridge. I got into transportation because of the Golden Gate Bridge when I was a kid. I loved this bridge. But people, I get excited. Mr. Iwasaki mentioned this earlier this morning. I get excited when a new sensor is placed out on the roadway network. But are there incentives for transportation agencies to make sure that the underlying hidden infrastructure is as good as it can be, is as advanced as it can be? So incentives across the board for the individual, let's say, people who are doing the work, for them to become more educated and more inspired by implementing advanced technology, and for the agencies who are building and maintaining the systems as well.
Mr. Voigt.
Thank you. I go back to address the question to some of the remarks in my testimony. I think that that most pavement decisions right now are really based on a first cost or a lowest cost method. That really is not necessarily easily linked to doing more sustainable construction, unless you include within that decision process those benefits and economic impacts of the longevity and the other things that are associated with sustainable practices.
And that, if you'll permit me to interrupt, that's basically what I was getting at in regard to strategic planning, and I think you're getting to that point.
Yeah, we've looked at a number of research studies that indicate that there's some benefits that simply we haven't accounted for in the methods that we're using in the processes we're using. So what we feel that at the federal level could really be helpful in this regard is to develop a strategic framework for including those factors of sustainability and those benefits and features. Perhaps creating that and deploying that within the more local agencies, that would be motivation, I think, and guidance perhaps to allow that practice to pervade across the country. But I think it needs to, personally, I think it needs to start at the federal level to provide that framework and that guidance to go on down.
Thank you, Mr. Chairman. If you'll permit me to allow Dr. Poe to respond as well. Thank you very much for your generosity, Dr. Poe.
Similar to what was said, I think this incentives and some reward for challenging the community to further pursue green transportation. As I was saying just earlier to Chairman Wu, we have researchers working on soil erosion, we have researchers working on pavements, we have researchers working on traffic congestion and traffic signals. But by calling attention to this and giving incentive for the states and universities to work on this problem, brings those collaborations together, and I think that will advance the whole area significantly.
Thank you, Mr. Chairman. I yield back.
Thank you, Dr. Gingrey. And the gentlelady from California, Ms. Richardson, is recognized for 5 minutes.
Yes, thank you, Chairman Wu. First of all, a statement for all of the panelists that we have here. Much has been said about providing additional funding for research. What I'd like to respectfully request that you provide to the committee is specifically how much do you think would be needed and for what specific projects? As we go through looking at safety loo reauthorization and various appropriation changes that we can do in the upcoming year, if you give us specific examples of what you'd like us to consider, I'm sure the chairman and others would welcome that thought. Mr. Iwasaki, coming from California, I apologize that I wasn't here to properly welcome you to the great area here of Washington, D.C., but California is known to be at the forefront, and more people need to know the tremendous work that's done at Caltrans, so thank you for being here. My question for you is, has California carried out any cost-benefit analysis, which is leading really into the last comments that were made, for specific technologies and materials that you described in your testimony? If so, what were your findings, and how do life cycle costs and benefits affect your decisions about which technologies and materials to use?
We're currently analyzing the cost-benefit ratios for a lot of the technologies that I mentioned, this system-wide adaptive ramp metering, those kinds of things. We did a 18-month project and deployed signal synchronization and down in Los Angeles area, as well as a swarm project along the 210, which just has dramatically improved the throughput through that corridor. And what we're doing now is we're analyzing the benefit cost information then to pass on to other regions for that technology. We have done some benefit cost analysis on some of the demand management strategies like freeway service patrol. In some cases where you have a highly congested corridor, it's 22-1, and it's better than any new freeway STIP project that you could ever achieve. But it's not really sexy. It's freeway service patrol. But as far as getting people on the move, it's a very, very effective tool. I think some of the things in the future, what we're trying to do is we're trying to, on all our corridor mobility improvement account, the $19.925 billion bond, the $4.5 billion worth of projects, those are we're doing before and after studies to see how effective the change was made. As far as materials are concerned, we don't do a lot of benefit cost analysis on our material type selection. We do it based on, we design to a certain life. So if we want a 20-plus year pavement, generally we go to Portland cement concrete. If we do a rehabilitation project, we'll do an asphalt concrete. And so in those cases, we're driven by past practices.
And some of the other members spoke about the fact that when you're responding to bids, it's typically on a initial cost perspective. Do you find that your states are being more supportive of looking at the more lifespan costs and making sure that they're really evaluating the cost of the project effectively?
Well, absolutely. If you look at the rapid rehab project that we did at DeVore on I-15 heading to Las Vegas, it was done in around 17 days. It costs a lot more money initially, but it put the utility back in the hands of the public. I say you're going to take your castor oil over an 8-month period, or you're going to do it over a 17-day period. Most people would rather do it on a short-term basis. Currently, we're rehabilitating the boat section in Sacramento. We did each direction in 10 days, and we used the new kind of a fast-setting concrete mix design there, so it would limit the amount of shrinkage and those kinds of things. And that project's going to last another 50 years. But we had to take traffic off of it. And so it costs us more money up front, but the benefits far outweigh the initial costs.
Okay. And Mr. Voigt, a couple questions for you. You note in your testimony that many state transportation departments do not consider life cycle costs when making decisions regarding transportation infrastructure. How does the concrete industry determine life cycle costs, especially when multiple variable factors such as the cost of fuel comes into play? What research is needed to better understand the life cycle costs of transportation infrastructure?
Let me clarify that where the states are not using, in many cases, and got to be a little bit careful with making judgments across many states because the practices vary so widely. But in general, where we see less decisions being based on a life cycle basis is on the maintenance and the preservation end of the system. And so that's an area where we feel there could be more done. But going back to linking the usage end, this is the key piece to us. The usage end of the roadways, there are many sustainability benefits and or disadvantages depending on what you're looking at for your project that are simply not accounted for in the process. And we feel that, again, if we begin to account for those, and that will in and of itself incent the use of of more sustainable practices. It'd be simply looking at it maybe from a local government perspective of saying we're paying so much energy for lighting costs, but if we use this pavement selection, we would reduce that cost on this side of our budget, while we may have to pay a little bit more up front on this side of our budget. But in the long run, it will take down the entire budget of the agency. It's a matter of looking just simply not at the paving materials and the projects themselves, but looking across the perspective.
Thank you, Mr. Chairman. I yield back.
Thank you. The gentleman from Michigan, Dr. Ehlers.
Thank you, Mr. Chairman. Mr. Brubaker, what is the total annual budget of the Federal Department of Transportation?
Yeah, that's a. I thought it was closer to 7. It's in the high 60s. I'll get you an exact number for the record, but it's in the high 60s.
Okay, now that includes what? Is that everything? That
Yeah.
includes the FAA as well as the highways, et cetera?
No, I don't think. I think my staff informs me that that's the total budget.
So how much did you say, 80? Or
No,
60?
close to 7. It's in the high 60s.
I see, 70. Okay, and what's the budget of RITA, your little niche there?
Well, that's a great question. The appropriated budget for operations is in the neighborhood of $12 million. But that doesn't include fee-for-service organizations such as the Transportation Safety Institute, which adds probably another 20 million in revenue, plus an additional, and I'll get you the exact numbers for the record, plus the Volpe National Transportation Center, which is a fee-for-service organization that adds another 160 million or so to the operation.
Where does the money for that come from, then?
That comes from customers on a fee-for-service type.
And who are the customers primarily?
The customers are primarily the transportation modes within DOT. So it's a fee-for-service type arrangement.
Okay. The reason I'm asking these questions, do you know of any private sector company with an annual budget of $70 billion, which would have a research budget of somewhere in the low millions?
No, sir, I do not.
And I suppose you understand there's a reason why they spend more than that.
Yes, sir, I do.
Because they want to stay in business, right?
Yes, sir.
And you can't stay in business, you can't do a job without the research money. I think the reason I'm asking this is we have to publicize the fact that the government is being very stupid in this. And I have to implicate the Congress in that as well. The private sector has learned that if you want to stay alive, you have to do the research. This committee has responsibility for the research and direction and funding, and yet we are advisory in a sense to the Transportation Committee. When we went through the last go-around, and Mr. Wu, our roles were reversed then, but you recall we worked together very hard to improve the amount of funding going for research in the Transportation Department, particularly in RITA. And it got knocked down by the House Transportation Committee, got down even more by the Senate Transportation Committee, and we had submitted was not nearly as much as you should have. You can demonstrate that research money saves money in construction, no question about it, and yet we're not doing it. We're throwing away a lot of taxpayers' money in the name of getting projects done without researching the best way to do it.
Now,
And I think we simply have to publicize this so that next go around we can give you the kind of funding you need. And I'm not saying you're not doing a good job. I think you're doing a great job with a small amount of research funding that you have. But it's just unconscionable to me. Now, it's not just because I'm a physicist and a researcher, but any business person looking at this would say, good grief, if we can do enough research to add just an extra year to the life of the concrete we're laying this year, how much do we save? Well, obviously, you'd save enough to pay for the research many times over. Similarly, the different types of concrete, as Mr. Voigt mentioned, and all the research that's being done there. And similarly for asphalt, we're being penny wise and pound foolish. Now, this is pretty much the end of my sermon, Mr. Chairman, and I know I'm preaching to the choir when I talk to you or to this group, but we really have to make that impact on the transportation committees on the next go-around. Mr. Brubaker?
I'd like to make a couple of clarifying points just so we understand what we're talking about here. The numbers I was giving you, or I gave you, are the operational numbers of RITA. And then staff reminded me that there's an additional $27 million going for the Bureau of Transportation Statistics, which is the data side of the house. But just to be clear, I want everybody to understand that the total research budget of the department is almost $1.2 billion. So there is sufficient, we can talk about sufficient. I mean, what I want to make sure of is that we understand that the total research budget dollars that are allocated for research-related activities in the Department of Transportation amount to about $1.2 billion a year. Now, getting to your question, I don't know any similar ratio in a technology intensive private sector firm that would even equate to that. But so your point's still well taken.
Yeah, and I'm not criticizing your department or your operation in any way. I want to make that clear. That's not the reason for the questions. The reason is simply to say we have to do better than that. And if we're really talking about running government efficiently, then we have to design projects efficiently, and you have to build them efficiently. And I'm convinced that we could add a considerable amount to RITA's budget and have it pay for itself by doing the research properly and building bridges and highways properly and so forth. So this is just a plea to you to help us in our battles with the Congress next time around to make sure you get the funding that you need, and that will really pay for itself. I think the states will all agree with that too. And I know individual states spend money on research too. And when I was in the Michigan legislature, I helped get some funding for concrete research at one of the universities. But putting it all together, we're just not doing it as well and as efficiently as we could. And so let's all join this battle together next go around and make sure we start off from the blocks running and make a very strong case. Thank you, Mr. Chairman.
Thank you, Dr. Ehlers. Mr. Brubaker, when Dr. Ehlers is trying to push research money your way, my recommendation is to just accept it graciously, especially when you take into account the building dollars that come in from city sources, county sources, state sources, and what I would guess would be proportionately smaller research budgets at those levels. I'm going to try to squeeze in two quick questions.
Mr. Chairman, may I just add one comment?
Of course.
I'm sure that you're aware that if we do increase the research budget, that a good share of it gets shoveled off to Mr. Bertini's institute and other institutes in Oregon.
That thought had not occurred to me, but I'm glad you pointed that out. Metrics. We've had some sort of cursory discussion of metrics, but how do you measure lifetime environmental impact or energy costs or other costs? What methods exist? What are the metrics that are being used? To the extent that any of you all can expand on the discussion that we've already had, I'd greatly appreciate that. And if we could do this quickly, then I'll try to rush on to a second question.
I can respond to that to some degree. The National Research Council of Canada has done some work in looking at the life cycle of paving systems. That includes all of the energy and the embodied energy in the materials that are used, as well as the energy used to place the pavements, to recycle the pavements, or I should say to rehabilitate the pavements over many cycles. They did a 50-year analysis. That was information that we had. It's cited in my written testimony, and I think the A similar thing would be very helpful here. Now, the one thing the Canadian study did not include was the operational fuel issues, but that could, I think, also be included, linked up with some research on the fuel efficiency issues. So there is some work that has been done. It needs to be expanded, but I think it would be greatly helpful to making this connection and this framework that we need to really put those sustainability issues into practice.
Thank you. Dr. Bertini?
In my testimony, I talk about standard metrics that are used, and I think we know how to estimate the emissions, let's say, costs of different alternatives in different projects or products. We know how to estimate the noise impacts, fuel consumption impacts. One of the problems is that these impacts accrue to different people in different ways. So in the case of a project that Caltrans wants to build, their capital budget has to pay for the additional capital costs of the 17-day project versus the 8-month project. The benefits, if I save time, or if I live near there and I breathe fewer particulates, there isn't some slot machine where coins are coming out and going into my pocket. Those are costs that are spread out and not accounted for anywhere, even though they are a benefit to society. So I think a lot of the, let's say, green and sustainable benefits of projects are not ones that show up in a capital budget. They're ones that show up over a much longer term in people's health, in the health of our economy, and so on. So I think incentives and rewards for finding ways to include those slightly more intangible benefits are really important. There was seminal work done at the University of California, Davis. I should say I'm a product of the UTC at UC Berkeley. So the UTC program is, creating generations of transportation researchers, and in my case, UTC directors. But at UC Davis, Mark DeLucchi has done a lot of work. It would probably fill this table with trying to quantify the full cost of transportation on society in some of these unquantified ways. So a lot of that's already been established. It's just a question of how to account for it.
A lot of these methods exist. Some need to be disseminated, and then to the extent that others are missing, I'm particularly interested in that, particularly with respect to new materials or methods. Does anyone else want to? Dr. Poe.
Just on congestion specifically, one of the things we've spent a lot of time trying to relate to the public and media, how do you convey this congestion thing? And travel time is very well understood. How much time does it take you to get from where you're starting your trip to your destination, and how much time you actually spend in congestion? The public measures this on a daily basis. But the other thing that's gaining increasing importance is that reliability. And that reliability is how much extra time do you have to plan for to make it to your trip on time. And people really understand that. And so trying to come down to this hearing itself, how much extra time did you have to budget in your day and your trip to make it? And it plays very well, and the public understands that, and they're paying the price right now with congestion.
Anyone else? Mr. Iwasaki.
I'll just add this. Through the bond initiative, we're looking at how green our projects are. And it's project specific. The problem is we don't have data for every project, and so we're having to go put detection systems in then to gather the information to correlate the reduction in carbon, for example. And so that's the other piece, is that we need data. We need reliable, good source of data then to make the calculations, and that's not everywhere in the United States. And so we need to kind of keep that in mind when we do these things. It's not a model. You have to get down to the specifics of a project and the benefits, and that's what's harder to do. And we work very closely with one of the UTCs, UC Davis, on the sustainability issue.
Thank you very much. Since I seem to be the lone person standing, I choose to recognize myself for an additional 5 minutes. What has happened in the course of this hearing is one graphic illustration of what you plan for, and then sort of the dispersion of time that can occur. My flight might leave from Dulles at 6:15, and if everything goes right, I could leave the Hill at 5, but that would be very unwise. I try to leave at 3, and if everything goes right, I'm at the gate at 3:45. But if things go wrong, and that happens about 40% of the time, that time gets taken down, and I have to plan for that no matter what. And I think the general public gets that very, very well, and I just want to work with you. so that we can all get a little bit more certainty on our planning. We can enhance our research budgets to where we need them to be on the transportation side. I wanted to ask a pretty general question about workforce training. Until I got more familiar with some of your work, I was quite frankly a user of the end product or service, but not very well aware of y'all's work. And I'm sure that there is not only a huge workforce in building the transportation network, but there are significant issues in workforce training on the research side and on the implementation side. And if you could try to address some of those workforce issues, whether it's at the research end or at the far end of actually getting things built and everything in between about removing barriers to better transportation system, if you could try to address that workforce issue and appreciate that.
Yeah, just on the research side, if I may, and this is a dangerous thing to say sitting at a table with a whole bunch of civil engineers, but you know,
and they are civil,
and they are civil with an emphasis on the civil. The point you were asking, or the question that you were asking before about data is I think it illustrates what I'm about to say. We really have to have a better understanding of the holistic performance of the supply chain, of passenger movement, of system performance generally speaking, and then understand and mitigate whatever impacts that construction projects may have on that on system performance, disruptions, man-made or natural, have on that system performance. In order to best do that, it's really imperative, and particularly when this comes to planning as well, that we take an interdisciplinary approach to the research, that we bring not just civil engineers to the table, but we bring economists, business people, social scientists, behavioralists, so that we have this holistic understanding of system performance and disruptions to the system and what that may mean for the economy and how people respond and react, as well as getting into the materials side of sustainability issues, but also the business side of it. For example, when Mr. Iwasaki was describing the 17-day project and the reason why they do that, it's because they recognize that there's an economic cost to that disruption that has to go into that equation when they determine what's the best course of action for the public. And so that's what I would say in terms of workforce, to ensure that we're training researchers and opening our aperture, if you will, to embrace folks from multidisciplines and not just the civil engineering community anymore. Not that they're not important and critical to this, but it needs to go beyond that.
Mr. Iwasaki.
About 50% of the managers in California state government are eligible for retirement over the next 5 to 7 years. That includes Caltrans, and that really concerns us. Of course, that's not me. I'm too young for that yet. But ultimately, I will retire, and so somebody has to replace us, and so that was a focus. So with this influx of new money from our bond initiative, we created what we call ICE. It's Industry Capacity Expansion. So we need more aggregate because we're going to build more. We need more people to go to the trades. How do we go out to the grammar schools, the grade schools, and get people energized about going into the trades, to be finishers, concrete finishers, to drive trucks? And then how do we work with the UTCs to generate the next generation? Like Dr. Rob here, he's a product of the UTC system. So he's because you fund UTCs, he's a product. Now he's a leader. He's one of the directors of a UTC. It's a great process. But how do we get these people energized into going into civil engineering rather than becoming the next owner of Google or something else? Because that's really what our video games and those kinds of things. And so we're trying to energize the young people. And also we have the Garrett Morgan Symposium where we adopt high schools. Caltrans has, we try to adopt 12 different high schools in California and talk about science and mathematics and get them interested in not only engineering but the trades as well. And so we recognize this is the problem. How do we rebuild America? How do we rebuild America smart and use existing labor? We can't. We need more people. And so we're trying to do that through various tools.
Dr. Poe, did you have something? Dr. Bertini.
Going in order. It is safe to say that we have a workforce crisis in the transportation field, and many of us are working hard to respond to that. And the technology transfer and education mission of the UTC program, in addition to research, is critical to that. And it's exciting to me in our UTC that I believe we have about 12 different disciplines working on projects, working together. I am a civil engineer, but my colleagues from statistics and computer science, urban planning, geography, psychology, and landscape architecture and more are working together, sitting around the table, working to solve problems, and that extends to students. So you visited our Intelligent Transportation Systems lab, and we have students there from not only civil engineering, but urban planning, statistics, and computer science, and they're working together on projects and learning to communicate in each other's language, which I think is part of this issue. Communication from the various disciplines is a little bit different. So I think the workforce crisis can be solved. There are some easy things in my written testimony that I talk about. So part of it has to do with funding. The other part has to do with some policies that could be easily changed with regard to out-of-state travel. So a staff member of a transportation agency in Oregon wants to come to Washington, D.C. for the Transportation Research Board annual meeting. Perhaps they work on their own time on a paper that gets accepted for presentation, but the agency policies won't allow them to leave the state, won't even allow them to spend the night in Washington State. So I think thinking about the fact that we want to retain the top talent that we have and giving them opportunities to share knowledge about their projects and learn about other projects in other states, I think is a very small price to pay, and those policies could be easily changed.
I represent a lot of companies that have laborers, and it's a challenge that to get practices, get those folks to the point where they're able to apply the technology. What we started in 2006 really was the National Concrete Pavement Technology Center. It's centered at Iowa State University, and we took a different approach with that, somewhat based on a frustration level on how long it takes for new technology to come into practice. And we hear different people say, different things. And our estimation, it's somewhere between 10 and 15 years in the transportation area for new technologies to really pervade practice. And that's just not good enough. And so we put a technology center together, and the idea behind that was collaborative research. And we feel when we involve the industry with the states and the Federal Highway Administration together, creating the technology and doing the research, that the acceptance to put into practice should be shortened, and we're starting to see some fruits from that. So I think as we look forward to, new technologies and sustainability and energy efficiencies and many of the things we've talked about this morning, we've got to also factor in that working together is the way to get that into practice faster. And we've really looked at it that way in the way we're approaching all of our research and technology areas. The last thing I would say is, in our industry, we are just now starting to use technology, putting technology on our sides, webinars and those types of things as just additional ways to get the information into the hands of the people that need to do it. For many of the challenges that we see out there from our traditional educational approaches, people can't travel across state lines, you can't do regional seminars, we have to find other ways to get the information into their hands.
Mr. Voigt, you talked about the program at Iowa State that your organization was instrumental in setting up. I've seen Dr. Bertini's Transportation Research Center. Is there a role is there a role for our community colleges apart from research in this human training need?
I would think yes. I would think that there could be very interesting benefits to that, and some programs that could be created at that level at a time in a young person's life when they're still maybe looking at what it is they want to do that could inspire them. And we are, I don't think, doing a lot in that area that I'm aware of across the industry, the transportation industry. I think that sounds like an interesting idea.
Dr. Poe, anything to add, or we have further comment?
Just want to really quickly add, at the community college, we actually work with the community college to help train equipment operators in the Stockton area. So we have a joint program with the community colleges there. We also have a program with the community college to help sign up the DBE participants, to explain how to fill out the forms and those kinds of things. And so that helps us get more DBEs on our federally funded contracts.
Just real quickly, I'll just say that when you invest in research, the workforce training is a byproduct of that. You not only invest in the researcher doing the work, but the students that are helping the researcher do the work, and it helps broaden the workforce. We've added a technology transfer component on researcher proposing projects. They have to get funded. They have to show a path that they're going to take technology transfer training. So we don't even fund projects through our UTC now that don't have that built into the whole project from the start.
With respect to intelligent highway systems, is there a interoperability or compatibility issue? And I'm asking this question because in other contexts, for example, in first responders, we have a significant interoperability compatibility issue. Is there a parallel issue in intelligent highway systems?
I think it's fair to say that there is a concern, but it's been somewhat obviated by the fact that we've got an intelligent transportation system architecture that we've more or less prescribed. We've laid it out there for people to build to. So we've got we've got an architecture that establishes certain communication standards, certain communications protocols to ensure interoperability for that very specific reason. And we're in the process right now of refocusing, re-energizing that architecture, particularly at the communications layer, to ensure interoperability in the future. So it is a significant concern, particularly when you've got new communications capabilities that are coming online that we haven't really dealt with before, like wireless communications and Wi-Fi and WiMAX and some use of cellular and radio spectrum that we're interested in exploiting to enable future intelligent transportation systems applications. So it's an issue, but I think we're working hard to make sure that it doesn't overwhelm us and that we can ensure interoperability.
Okay. I have many other questions that I will either submit in writing or just keep to myself until some future date when we meet in a far, far better world where the premium of time is a lot less. But I do want to ask one further question of the panel, and particularly Dr. Bertini. Sometimes I'm a quick adopter of technology. Most frequently, I'm a late adopter because I want to make sure it works. The one thing that would drive me to have one of those little display screens on my dash that shows a map of the street grid, I've seen in your laboratory the current traffic status from red to yellow, I'm sorry, from green to yellow to red, I believe. There's this horribly slow way of getting traffic news through the radio. And I've frequently wondered, why does this late model car not have a little pop-up so that I can access not only the map, the static map, but I can access the current flow information on the highway grid? Does that exist and I'm just not using it, or please, go ahead, whoever wants to take.
In California, we have predictive travel times, so we have the algorithm set up to give you from on the changeable message signs from, let's say, Novato to SFO, so that you as a traveler, if you take that often, you're going to say...
Oh, no, I've seen those, and
Okay.
I really appreciate that. I'm just wondering if...
In the next generation of we just recently were the recipient of a Safe Trip 21 grant, actually the only one so far at Caltrans. We got it at Caltrans. It's a $12 million proposal, public-private partnership, where we're going to use the next generation of cell phones, which are GPS-enabled, which will give you data from all over the arterial. So the plan is to send thousands of these phones out in the Bay Area, San Francisco, Oakland, Bay Area, and then get information on travel times on the local arterials as well as the freeways. So you'll be able to plug into your dash a nav unit that says shortest trip, shortest time, trip, and that's what you're really looking for, right? I mean, you're looking for the ability to
Will
maneuver
I have
through
to get
time.
new hardware in order to do that?
Well, it depends. I mean, it depends on what kind of nav unit you have, but possibly, yeah, absolutely. But that's the next generation of nav unit that we're taking the embedded communications and we're putting it into the consumer's hands, and then using those as probes.
I'm not sure if everybody on the panel is aware of it, but that capability actually does exist today. There's really a handful of companies that produce GPS devices that actually provide real-time some provide real-time, some provide probe data, some provide historic data. There's one in particular that actually acts as a probe in a network that you can use leveraging Wi-Fi communications. It's a company from California called Dash. I actually went out and bought a unit myself because I wanted to test it. And there are several hundred other folks in the area who have them, and it acts as sort of a self-contained network, so I can see where other people have gone before me real time and pick up on that data, and it's integrated with this historic data that's from probe data from vehicles, delivery vehicles, commercial vehicles, and such, and it tells a much better picture. Now, is it perfect? No, but does it tell me that, you know, I've got congestion on Route 66 when I'm trying to get on the same flight probably you are to the West Coast, to Dulles Airport, and that I should take an alternative route? Yes, it'll do that. Not perfect, but it's pretty darn good. Likewise, I was just, you know, recently using I believe it was a Garmin unit that I got from a rental car company that I was late getting to Logan Airport, and it told me to take an alternative route. So, and I don't know what they used for that, but it was very helpful. So that technology exists. It's not quite perfect. What Randy's describing here is and I'll change that to Mr. Iwasaki for the record.
You can call me Randy.
Okay. What Randy is describing is going to provide a much higher level of fidelity in the data and much more current data, as opposed to a probe from somebody that went down the road, 5 minutes before I did or 10 minutes before I did. When you've got 10,000 phones and eventually 100,000 phones and millions of phones out there that are GPS enabled and everybody's sort of acting as a probe, privacy protected, hopefully. I mean, that's the game plan, making sure that we're protecting privacy here, but at the same time getting better situational awareness. That, in effect, is the goal, so that people can plan their routes better and avoid traffic and keep traffic moving, which is totally green.
I'd invite the committee to come to California and kick the tires of ITS. If you want to come down into the Berkeley area, we can take you out to the Richmond Field Station and show you the next generation of these types of technologies, ITS technologies. Absolutely.
Why don't we go to the motherlode of traffic and try it on the Hollywood freeway on a Friday afternoon?
We can take you down there as well.
That's the goal.
Absolutely.
That is the goal.
Dr. Bertini.
These are great examples, and I think the answer to your question is some places and sometimes you can get real-time information that is useful for you. The problem is this is a big jigsaw puzzle, and I've been involved in this for maybe the last 13 years and have seen different generations of these companies with different technologies, different ideas. I've visited other countries and kind of kicked the tires of different systems in Japan and Europe. We've done some research with BMW looking at the real-time traffic information system on some of the Autobahns there. So if you go to a place that's kind of like a test bed or has data in place that has been validated, my concern is that what we have is not consistent across the country. So if you have a vehicle and you want to use it in Portland, but you cross the Columbia River to Vancouver, Washington, it may not work because the sensor infrastructure may not be there. The communication system may be different. So we've got pieces, we've got demos, we've got examples, and we've got lots of great ideas. But what we don't have are fully deployed projects. I think what we would all like would be something that is real-time, that's available to everyone, that's low cost, that's proven, that you can customize so you're not getting information that you don't need or information that's old. Maybe it's even alerting you, so you might get a message that you need to leave for Dulles Airport now, or you might get a wake-up call in the morning and it would say, take the metro today because the freeway is going to be all jammed up. So the idea that each user can interact with the system, so they're not getting information that's outside their purview, I think is where we're all interested in going. Still have a ways to go.
Terrific. Thank you very much. I just want to, as I was listening to you and the challenges that we face, it's a challenge, it's an opportunity. You all, it's kind of like Dr. Goddard fooling around with sounding rockets in the 1920s. Folks on this side of the dais, it might be like being a congressman and having Al Gore in 1975. Small political joke. It's a very small one. But before we bring the hearing to a close, I want to thank all of our witnesses. We look forward to working together with you all, with Republicans and Democrats, everyone who is interested in helping move people the way that they want to be moved, efficient manner, and particularly in the next reauthorization of the Surface Transportation Bill. The record will remain open for additional statements from members and questions and answers, follow-up questions that the committee or individual members may ask of witnesses. I want to thank the witnesses for their tremendous flexibility, tolerance, and patience, and also the attendees in the room today. And with that, the witnesses are excused and the hearing is now adjourned.